This is our fourth and final June workshop session for the month. My name is Adam Capriz. I work for the Holland Computing Center, so I'll be your instructor slash disembodied voice for this session. It's a fairly small group, which is good, so we can be pretty informal, I think. Let me start off by introducing. So first of all, can everybody hear me okay? I'm not speaking in the wind. You can give a thumbs up. Awesome, thank you. I'm always a little unsure about that when I start. So let me introduce the other HCC folks that are around. We should all have HCC staff after our name in the participant list if you see us. So we have Emily, she's an application specialist. We have Colin, he just started with us. He's a shiny, fresh UNL graduate. We have Mohammed, he's an application specialist as well. And we have Naruk, she does web design stuff and some database research stuff. So they're all going to be around. So if you have issues, with things not working, or you're having other kinds of problems, you should feel free to ping one of those folks if you need help. Or if you need help, you can also do the little red X no thing on your Zoom reaction panel, and somebody will ping you in the chat to see if we can sort it out. So today we'll be talking about the Conda Package Manager, which is, so first we'll talk about using software on HCC via the module system. And then we'll move on to talking about Conda, which has sort of become the de facto way to manage scientific software in environments. So Conda is a really great thing. It lets you do a lot of stuff. We'll talk about how to use Conda, a Conda environment in Jupyter. So Jupyter Notebook obviously is very popular now. And so it's pretty straightforward to use a Conda environment in a Jupyter Notebook on HCC. So you can create whatever custom environment you need and use it via Jupyter. So are there any questions from anybody before we get started? Does everybody see the slides? Everybody find the website, all the links and everything? So if there's any issues, please ping one of the folks with HCC staff after their names. Okay, so the slide deck, these slides are available at that Go link. The Conda lessons that we'll be using are this Conda for data scientists. Full disclosure, it's still sort of in a beta testing status for software carpentry. So software carpentry hasn't fully accepted these lessons yet, but I think they're good enough to use. So there may be a few hiccups because they're still kind of in a beta status. So if something doesn't work exactly as expected, don't panic. We'll get it figured out, and just again unmute yourself if you have a question. Since there's a fairly small group today, or if you're having a specific problem, feel free to put something in the chat or ping one of the people directly. If you have questions and you'd prefer to use the chat for questions, that's fine. Please feel free to do that. And one of the helpers will pass those along to me. Sometimes it's hard to monitor the chat while you're doing the teaching as well. So the workshop website, hcc.unl.edu, click on the big honking link on the front page. That'll take you to that. We have our documentation, hcc.unl.edu/docs. I feel like we have a lot of information there. It's not always perhaps organized in the most efficient way to find. So the search bar is your friend on the left. The search bar works pretty well. So if you're looking for something in particular, just use that search bar, and I think it'll save you some time. Our support email, hcc-support@unl.edu. All the UNL domains you see, those are largely, those are sort of historical things, but we do serve the entire system. And actually, we let anybody from any higher education institution in the state use HCC resources. So if you're from one of the other campuses, you're welcome to use HCC. If you're from one of the state colleges, you're welcome to use HCC. We've even had folks from high schools and stuff in the past use HCC. So basically, if something is resident in Nebraska and involved with education, you're basically welcome to use HCC resources. So objectives for today. We're going to talk about the module system. I'll probably use the word module and LMOD interchangeably. Module is sort of the generic term. LMOD is the specific software used to do this. There are other software that do the same type of things in terms of managing modules. HCC uses exclusively LMOD. So if I interchange the words of module and LMOD, just they're essentially identical. So forgive me for that, and just hear module all the time. And basically what this does is it lets us, that's how we manage all the software we have on HCC. So we have literally hundreds of packages installed, and without some way to manage those in the same way, it would quickly devolve into chaos. So we use the LMOD software module to manage those packages, and we'll go through some exercises on how to use it. You don't have to become an expert. There's probably 5 or 6 commands that you will need to know for a module, and that will get you everything you need to do. Then we'll talk about the Conda Package Manager. So we'll go through those software carpentry lessons, and talk about how to use Conda to create and manage custom Conda environments. And then again, I got that in there twice. We'll use Conda environments in Jupyter. We'll do a little demo of how to create a Conda environment and use it in a Jupyter notebook on HCC resources. So running applications on HCC, again, all the applications are loaded in individual modules. And basically what the modules do is they dynamically change the environment that your program is running in. So if you didn't have module, you would have to manually set up each package you wanted to use. And if you want to switch versions, you would have to handle that. If you wanted to, if you have to worry about conflicts with things because some software will conflict with other software, you would have to manually do that. And again, it would quickly just devolve into an unmanageable mess. And so that's where the module system comes in. It's your friend. It does a lot of this stuff for you behind the scenes, and you don't have to worry about it. All you have to do is essentially do module load to use a particular piece of software. And by and large, stuff happens behind the scenes without you having to worry about it too much. So module it has a hierarchical structure. So there are certain modules that depend on other modules, and that's built into the way LMOD works. So for example, if module A is dependent on module B, then module B must be loaded first in order to load module A. And we'll do a little demo of that. That typically refers to compiler versions and OpenMPI versions or MPI versions of software. So if a particular software is built with the GCC compiler, you can have the same software built with the Intel compiler, but you can't use them both at the same time because they require different compilers as a dependency. And again, we'll do a demo of that. I'll do a demo of that in the shell. So the naming convention is pretty straightforward. So it typically follows the software/version convention. So for example, the 2.7 version of Python, the module name is Python/2.7. So we have Python/2.7, we have Python/3.5, Python/3.6, et cetera, et cetera. And everything is done using this module command. So we'll do a demo. I'll do a demo of that in the terminal. And again, if you don't have a terminal on Crane right now, please get logged in. And if you're having problems, please ping one of the staff, because we're going to switch over to the terminal here very soon. So let's do a little sidebar here before we get too far into this. So what if I want to use something else? We have hundreds of packages installed, but there are literally, I don't know, thousands or tens of thousands of packages. So it's just not logistically feasible that we would have everything installed, ahead of time. So there are a few other options you can do. So you can compile the software from source. This can be anywhere from a 30-second task to a 2-week task, depending on how complex the software is, how many dependencies it has, et cetera, et cetera. If something doesn't really have any other dependencies and all it needs is a compiler, you can probably get away with running configure and make, and it'll probably build fine and work fine for you. Like I said, on the other end of the spectrum, there are packages that have, double-digit number of dependencies. Those all have to be installed first. Those have to be installed first with particular versions. They have to be installed first with particular versions and particular build flags sometimes. And so compiling from source can quickly get to be overwhelming. But it's something to look at if you have something that you want that is a fairly simple thing to build. Feel free. We encourage that. You don't have to wait on us. Sometimes we have half a dozen software install requests to get through, and sometimes it could take us a little bit to get responsive. You're more than welcome to install software by yourself. That's something we completely encourage. So Anaconda environments are another way, and those are, again, Anaconda or Conda has rapidly become the popular way to, or the de facto standard way to manage scientific computing environments. So that's what we're going to talk about today. The third option is using and creating Docker and Singularity images. So if you're not familiar with Docker, I'll just try and sum it up and say that it's a way to encapsulate a complete environment and run it on a machine. So using Docker, I can install whatever set of packages I need, and I can run that on another machine that doesn't have those things installed, and it's encapsulated up. So I can take that Docker image and I can move it around, and as long as Docker is installed somewhere, I can run that no matter where I put it on what machine. There's some caveats to that. It's essentially Linux only, so you're not going to be able to run Windows with Docker. We don't support Docker directly on HCC because of the way it works. It requires elevated privileges. So it essentially requires root access to work. So Docker was originally intended as a sysadmin type tool for people to deploy multiple packages and things like that on servers that somebody manages, and it's not a multi-user environment. You don't have dozens of people logging in to use the thing. So we can't use Docker directly because it would require privileges that aren't feasible on a multi-user system like a cluster. But we support software called Singularity. And what Singularity does is it will essentially let you run Docker images without the elevated privileges. So everything runs as your user account, but it still lets you get 90% of the benefits of Docker. There's some things you can't do with Singularity that you do with Docker, but for most typical applications that scientists and folks want to run, it works just fine. So we have Singularity installed. You can, most of the time, you can directly run images from Docker Hub. So if you see a piece of software that has a Docker image, generally speaking, you can just run that image directly using Singularity on HCC resources, and it will, most of the time, it will just work. So again, it works best for sort of simple things. If you're talking about running things like a database or a web server and other things like that, then it's more problematic. And HCC has some ways to accommodate that. But it's generally useful for, hey, there's this piece of software that has a bunch of dependencies, but they have a Docker image. Just use Singularity and run that Docker image and move on with life. Or the last option, we can certainly install it for you. So we have a software install request form. So it's a little form there that you fill out that, you have your name and your email and some of the information on the package that you want. And we will certainly be willing to install that for you. Again, because software installation can be anywhere from a 30-second to a 2-week endeavor, sometimes it may take us a while to turn those around. So if you're going to need something in the future, it would be good to submit that request form, at your earliest convenience. And so that way, there's not a holdup while we get that stuff installed for you. Okay, any questions on stuff so far? Again, since it's a small group, feel free to unmute yourself if you'd like to ask a question or put something in the chat. I'd like this to try to be interactive as possible, as much as we can when we're all sitting in our own homes. We're talking about installing. So we question in the chat, are we talking about installing software on our work volume? Or also both of this. So you can install software anywhere you'd like under your directories. So each HCC user has 3 directories. You have a home directory, you have a work directory, and you have a common directory. For software install, I would recommend using either home or common. Work has a purge policy, so anything that hasn't been touched in 6 months on work gets deleted to keep it clean, basically. So that can play havoc with software installs because a particular file might not get accessed, but if it gets deleted, it'll cause issues. So I would recommend if it's a small package, I would just put it on home. If it's larger, or if you want to use it from either Crane or Rhino, you can put it on common. Then it'll be available on both machines. There's a little bit of things to be aware of when you build software and run it from 2 different machines. Sometimes that can be an issue. So probably to start with, I would recommend home for software installs. Another question, so work is mostly forbidden. Yeah, so work is the place that you want to store your input, your input and put your output essentially. It's meant to be the working space on the cluster. And again, I think we probably talked about work earlier, or we talked about the different file systems earlier in one of the earlier sessions. But just in case you weren't there, I'll quickly recap. So home is your home directory. That's where you are when you log in by default. That is quota limited, pretty small. It's 20 gigabytes per user, but we do back that up. The work directory, that's again meant to be a large space. That the quota there is 50 terabytes per group. So that's where you want to put your input and write your output to. The purge policy there is 6 months. So if a file hasn't been accessed in 6 months, it gets deleted, and that's solely to keep work functional. Otherwise, it would quickly get overrun. The last one is common. So sort of as the name implies, that directory is available both on our Crane resource and our Rhino resource. So if you have data that you're running, you're running jobs on both clusters, and there's data that you want to access from both, common is a good place to put that. Common is not as performant as work. So home is the least performant, work is the most performant, and common is somewhere in between. So we don't recommend doing heavy duty reading and writing to common, but if you have stuff that you want to use in both places, or if you want to have stuff that is you sort of store for a while, common would be the place to that. Common has no purge policy, but we don't back common up. So if you have stuff on common that is precious, we strongly recommend that you have another copy of that saved somewhere. Okay. Any other questions before we trundle along? Okay. So LMOD commands, like I said, you don't have to be a module expert to do stuff. The commands that are listed here are probably the only things you'll ever need to know. So everything starts with the module command, and then after that, there's a sub command to run. So for example, module avail, short for available, lists all the modules that are available to be loaded. So an important point with module avail is that that's not the list of all the modules. That is only the list of modules that are available to be loaded based on your current module. So remember, I said module is hierarchical. So depending on what modules you have loaded now, that determines what other modules can be loaded immediately following. So module avail, so that's a common mistake folks make. Module avail is not the complete list of modules. It's only the list of modules that can be loaded immediately. So module spider, spider is essentially a search command. So you can use it to search for a module. You can also use it to get more details about a module. So if you search module spider MATLAB, it will return all the versions of MATLAB. If you search module spider MATLAB /R2021A, in other words, you give it a specific version, it will give you more specific information about that module and will tell you whether or not it can be loaded immediately or whether or not there's other modules that you would have to load first. So module load does what it sounds like, that loads a module. You can also load multiple modules at once. You just put a space in between. Module unload, that, as it sounds like, that unloads the module. And again, you can give it more than one on the same line. You just put a space in between those. Module purge, that will essentially unload everything that's currently loaded. So if you have a bunch of modules loaded, but you want to get back to a clean state, instead of running module unload, module 1, module 2, et cetera, you just run module purge and they're all gone. And finally, module list, that lists all the currently loaded modules. So like most Unix commands, there's a help. So if you do module -- help, it will give you a list of all the module commands. There's certainly more than that are here, and you can do some fairly advanced things. But again, these are the basics that you'll probably need to know for 90% of what you need to do. We also have the software list available online because obviously sometimes it's easier to look things on a web page. So all of the software that is available on Crane is at that link. We also have a one for Rhino. And that's essentially generated automatically from the module information. So everything that's in module is on that list. Again, it's sometimes it's a little easier because it's searchable. So if you bring up the page, there'll be a box on the left you can search there. And let's see if I can just show that real quick. So software for Crane. Scroll down. So here's, it's a table, and there's 1,315 rows. But you can certainly search by name. So if I want to look at MATLAB, I search for MATLAB, and it tells me the name and the version. It tells me what the module name is. So that's what I would use for load. So it would be module load MATLAB /R 2012B. It tells me if it has any prerequisites. So again, because module is hierarchical, some things have prerequisites. So if I search for something like OpenMPI, so in this case, the 2.0 version of OpenMPI has, it's available with multiple compilers, so it has multiple prerequisites. So if you load any one of these prerequisites, you'll be able to load the module OpenMPI 2.0 module directly. Like I said, module 3 times, but that's okay. So let's go over and do some examples with the terminal. So can everybody see this okay? Is the font large enough? Again, I got 1 thumbs up. Okay, good enough. Let me know if it's too small. I can make it a little bigger yet still. So I'm using a demo account. So it says demo 20. Your login will say your username, obviously. So on both Crane and Rhino, what we do is we actually load some modules for you when you log in automatically. So if you log in and run module list, so you can see that we have some things loaded, and we do that essentially for common things that we think will be useful sort of universally, and it's good to have recent versions of things available by default. So for example, we have the GCC 10.2 compiler, we have OpenMPI 4.0, we load Python 3.8, we load Perl 5.26, we load Git, and we load Nano, which is a text editor. So at this point, I'm going to run the command module avail, and it's going to show me again what modules are currently available to be loaded. So if I do that, now we'll look through here and kind of see how these are organized. So I'm going to go to the bottom and kind of go back up. I think that might be a little easier. So as you can see, there's lots of stuff. So the spider command is your friend, unless you really want to look through literally pages of output to find something. Down to the bottom here. So if I scroll back up, so we'll see that things are organized with some headings here. So we see these core modules, and what that means is a core module doesn't have any other dependencies. So a module that's listed under core can be loaded directly. So I can run, so for example, there's meta CV, so I can run module load meta CV 2.3, and it just loads. So if I do module list now, so it's now loaded alongside all the other things that were loaded by default. So if I go back up, we'll see another heading. So we'll see GCC 10.2 modules. So these are modules that are available because I have the GCC 10.2 module loaded. So again, there's actually a 2-level hierarchy. So there's a compiler level, and then there's an open MPI. Are modules persistent, or do they go away after log out? Yes. So if you load modules and then log out and log back in, the only thing that will be loaded are the ones we do by default. So there is a way to save and load modules on every login, but by default, that's not how it works. So if you have modules loaded in a session and you log out and you log back in, those modules will need to be loaded again. Okay, sure. So these are the modules loaded based on that are available based on GCC 10.2. Then we have one other level, one level up. We have modules that are available because I have both GCC 10.2 and OpenMPI 4.0 loaded. So these are typically software packages that are MPI based. So if you're not familiar with MPI, MPI is a framework or a way to use multiple machines in a cluster. So you can write code that can run on more than one distinct server or distinct node in the cluster, and the software can use those nodes all at once. And so these are packages that are MPI enabled, basically. So if I go back down here, so let me do module purge, and we'll look at the difference here. So again, module purge will remove everything. So I do module list. Now I have no modules loaded. So now if I do module avail again, we can see that all I see that all it has is the core modules, right? Because I don't have either the compiler or the OpenMPI module loaded. So for example, if I tried to load, let's try Plumed 2.7. So if I do module load Plumed 2.7, tells me, hey, I can't do that because I essentially don't have the prerequisites loaded. So again, the spider command, again, so if you hit spacebar, that will page you down. If you want to exit completely, you hit Q, the Q key. So I can do module avail, and so every time I hit the spacebar, it goes down a page. If I want to exit out, I hit the Q key, and it takes me back to the prompt. So yeah, sometimes the navigation is a little bit archaic on some of this stuff. And generally speaking, for things like that, where it's what they call paginated output, it's spacebar to go down and Q to exit. So, or also the Control C is always a good thing to try too. So again, if I try module load Plumed 2.7, it says, hey, this module exists, but I can't load it right now because you don't have the other modules, the prerequisites loaded. So if I do module spider, Plumed 2.7 now, so I give it, so if I first if I just do module spider Plumed, it's going to tell me, give me some information about it and tell me these are the versions that are available. So now if I want to see what I need to do in particular to use a specific version, I add the version number at the end. Okay, and so now it tells me you need to load these modules before we can load Plumed 2.7. So I can actually do that all on one line. So just a reminder, right now we have nothing loaded. So if I do module load compiler HCC 10.2, MPI 4.0, Plumed 2.7. So the order matters here. So I need to have the lower hierarchy on the left. So the compiler is the first level of hierarchy. OpenMPI or the MPI modules are the second level. So those need to be left to right in ascending order, essentially. So now, if it doesn't return anything, that usually means it works. So if I do a module list, and say, yep, I have all those 3 modules loaded. Okay. If I want to unload a module, I can certainly do that. I'll go unload FluMed 2.7. Module list. So module unload OpenMPI 2.0. Module list. And then I run module AV again, they're available. And I see, so I have I have these GCC 10.2 modules available, but I don't have the OpenMPI modules anymore because I don't have the OpenMPI module loaded. Okay. The little D's you see, that means default. So if you don't give a version number, that's the module that will get loaded. Generally speaking, that's the highest version number available, but there are some cases where that's not true. Sometimes there are reasons for not just having the latest version be the default. But generally speaking, it's going to be the highest version number available. So for example, let me find one here. So MetaWrap, there are versions 1.1, 1.2, 1.3. So if I just do module load MetaWrap, module list, so it loaded the 1.3 version because that was the default. When you're running jobs and you're writing your submit scripts, you can certainly just put, the module name and not specify a version. And again, it will just use either the latest or whatever is marked as default. I would probably recommend always specifying a version. So that does a couple of things for you. That ensures that if we install a newer version, that it doesn't suddenly change out from underneath you. So, if you were just doing module load MetaWrap and we installed MetaWrap 1.4, then the next time you ran your job, it would use the 1.4 version instead. And that's, that could be bad. I mean, that could be confusing or give you results you didn't expect. And it also is an issue for repeatability, right? Which is the second reason. So when you specify a version, you are helping to ensure that things are repeatable, right? So any questions on what we talked about so far? Otherwise, we have a little exercise we can do here next. We need to load modules inside the script. Yeah, so generally speaking, you will want to load your modules in your job submit scripts. The jobs will inherit modules, but that can be an issue for repeatability. So yes, so best practice, yes, is to always put your module load line in your Slurm script right before you run the program. So the examples we have online. Let's see if I can find one. Let's see here. So submitting jobs. Let's do submitting an MPI job. So for example, in this example script, we do module load, a particular compiler and a particular OpenMPI. And that, again, helps to ensure that this script is repeatable, right? So when you run it later, you don't get a different version than you expected. So. Okay. Any other questions? Okay, let's then just do a little bit of an exercise because I've been talking a while. So here's some exercises to kind of run through. So first one is find a list of the available modules, then load one or more from the list you just found. Now try unloading them. Try to do it a couple of different ways. And then the third one would be to look up information about the R module. So try to figure out how many different versions there are, and then load a specific version, and then run the r-version command to verify that the version you loaded is actually loaded. And then search for a piece of software that you have or that you currently use in one of your, in some work that you do. If it's available, load it and run, a simple command with it. So let's give, I don't know, let's give 10 minutes to do those. And then we'll circle back, and if anybody has issues, or I can work through and kind of show what it should look like. And then, if you have questions or have issues or questions as you go along, again, please speak up or use the chat, and we'll be happy to help. So let's give that 10 minutes. So we'll go to 1:52, and then I'll come back and we'll keep going. So I'm going to mute myself here for a minute while I get a drink. So I don't think people want to hear me drinking, and then we'll come back in a few minutes. So thanks. So we do have a question in the chat. Will you talk about linking flags once modules are loaded? I have no trouble loading and unloading buff, and I can't get them to link properly with netcdf. Yeah, I feel your pain there. Yes, I will. We'll run through the exercises first, and then I'll talk a little bit about how the modules can help you a bit with some of the compiling and linking issues. It's oftentimes that's a very specific thing to what you're building, but the modules do try to set some flags to try and help with that. So I'll talk about that once we go through the exercises here in a couple of minutes. Sure. Some of the software, there's a bit of black magic involved to get the flags right and in the right order and get everything to work properly. So as I mentioned earlier, compiling from source can be anywhere from a 30-second to a 2-week endeavor. So okay, let's go ahead and keep going here. Again, if you didn't quite get through them all, that's okay. I'm gonna go through and show sort of what the answers are, but again, you can always come back and work through these later if you'd like. The slides are up online, obviously. So the first one is to find a list of available modules. So that's basically what we did before with the module avail command. So again, if I run module avail, it will show me everything that I have, again, based on the modules I have currently loaded, right? So because I have GCC 10.2 loaded, it shows me this list here. And again, to go down the page, I hit the space bar. And if I want to quit entirely, I hit the Q. Q is in quit. Couldn't think of a Q word there for a second. So the next one is load one or more modules from the list you just found, unload them, try doing it 2 different ways. So we'll just pick a couple of things here. So let's do module load, I don't know, OpenCV 3.1 and P7 zip 16.02. Right. So if I do module list, now those modules are loaded in addition to the ones we had loaded before. So I can do now, if I want to just unload those, I can do module unload OpenCV 3.1 P7 zip 16.02 module list. So another way to do it again is just to leave off the version number. So I can go back and just do the names. Oops, got to do load. And again, it will load the most recent versions available, which I think were the ones I did before. So 3.1, 16.02. I can also do module unload with just the names. All right. So there's a couple of different ways there to do that. You can use the version numbers or not. Again, for repeatability purposes, I would suggest always including the version numbers in your scripts. Okay, look up information about the R module. So for that, we're going to use the spider command. So I'm going to run module spider R. And so it tells me that, here are the R modules. So we have, quite a few versions of R from 3.0 to 4.0. You can also search for wildcards, essentially. So it's going to tell you other possible modules that match that. So those include the R, the word, the letter R, but they don't match exactly. So there are different ways to search, whether or not you want to search for just the proper name, or if you want to search for a string, for like something that's in the name. So let me see if I can find an example. So if I search for module spider next, so there's not a name, there's not a module that is just named the word next, but there are modules that have the word next in their names. So for example, next flow, next strain, so it will return those as well. Again, depending there's different ways to search with the spider command. But if you're just searching for a substring, essentially, you can also do that with the spider command. So how many different versions are available with the R? So there are, what is that? 1, 2, 3, 4, 5, 6, 7, 8. So we can load a particular version again by using the version number. So if I do module load R 3.6, and I use the R version command to verify. And so, yep, version 3.6.3 in this case. You'll notice that most of the module names are only, 2 significant digits. So in other words, the module name for R 3.6.3 is R 3.6. So we do that for a couple of reasons. So if we had a module for every last version of the R release, that would quickly get pretty messy. So, you would have an R 3.6.1, R 3.6.2, et cetera, et cetera. And so that would be pretty messy. And also, generally speaking, you don't really care about this last digit in the 3-digit version number scheme. That's what they call a bug fix release, or a bug fix version. So by naming the modules with the first 2 digits, what that lets us do is we can sort of upgrade these behind the scenes. So, but you don't need to change your module load statements then. So it's just a little bit more flexible than having, the full 3-digit version number. Not all software behaves that way. So some software versions, the version numbers don't do that. So in those cases, the module may be named a little bit differently. But for software that behaves that way with the x.y.z scheme, generally speaking, we will only have the module be named x.y. And then, behind the scenes, we can sort of upgrade this last digit if necessary, and it won't break your existing scripts. So that's why we do that. Search for a piece of software that you currently have. So anybody want to paste something in the chat that they searched for, that they used, that they were able to find? We have PyTorch. Excellent. Thank you. Yes. So that's actually a good suggestion, because I can demonstrate one other thing. So thank you. The check's in the mail. Module spider PyTorch. Oops. Spell it correctly. So if you look now, so we have a bunch of different versions of PyTorch, but now you'll see that the version number scheme is a bit different. So in this case, it's PyTorch / PyXX, right? So Pi352736, and then the actual so what that is that's the Python version, right? So we have PyTorch 1.2. So the 1.2 version of PyTorch is available for both Python 3.6 and Python 3.7. So that's what that middle bit means. That's the Python version. Most common, you'll see that for Python. We do have a few other modules that might do that for something else, like an R version. So in any case where you have a package that is available for multiple versions of the intermediate language, you might see that intermediate version number in between in the middle of the 2 slashes. It's usually pretty self-explanatory, Python, py. But if you're not sure, you can always just email us and ask about something. But that's a good example. So thank you for that. Okay. Let's see, we had a question in the chat. Please show the command where to add the command to load during the module during the job. Yes. So thank you, Colin. I think you answered that. But yes, you would want to put those in your submit script before you start running whatever program you're going to run. So hopefully that, yeah, Colin linked an example. So hopefully that that makes it clear. So, okay, any other questions on using modules before we switch gears and dive into Conda? Okay. Hopefully that means it's fairly clear to people. Again, if you have any questions, obviously feel free to email us after, email our support email. Most of the time, once you use the module for a little bit, it sort of gets out of the way, and you don't think about it a whole lot. So we did have another question about the linking flag. So let me talk about that a bit before we trundle on. So modules will oftentimes set some other variables that can be helpful to you. So let me find a netcdf module. So I do module spider netcdf, and so let's do 4.7. So the 4.7 module netcdf is available with several different compilers. So I've actually got it available now because I have 10.2 GCC loaded. So I'm going to do a module purge. So I want to get back to a clean environment. So then I'm going to do a module load compiler GCC 10.2. So this is a good opportunity to demonstrate the module show command. So you won't, unless you're building software or doing some other thing, more advanced things, you typically won't need to use module show. But it's a good thing to demonstrate here. So what module show does is it's sort of what it sounds like. It will show you explicitly what the module is doing. So you can see, we don't hide anything behind the curtain, right? Everything is available to see what's happening. So I'm going to do module show netcdf 4.7. Okay. So sometimes it can, if you're not familiar with the LMOD package, it can be a little bit cryptic as to what things you're doing. But basically, most everything module does is either setting or changing an environment variable. So in this case, one of the things it's doing is it's setting the netcdf environment variable and setting it to the actual install location of the software. And for things that are libraries or that might need to be compiled against, the modules also try to set some helpful things like LD library path, package config path, cpath. These are things that compilers or build systems pay attention to. And so the module is trying to help you find where the package lives when you're building other software that needs it. Doesn't always work. There's not one universal build systems. Most build systems pay attention to these variables, but they're, depending on how the package is written and some other things, it's not a sure thing. So it's helpful, but it's not guaranteed. So let me load the module. So for example, for right now, I just have the GCC module loaded. So if I do echo netcdf, so that will print the value of this variable if it's set. So in this case, it's not set yet because I haven't loaded the module. Now I do module load netcdf 4.7. So now if I do echo netcdf again, so now it's set. So what this can be useful for is if you need to, again, link against the software or point to the location of the software, you can use that variable and you don't need to use the full path, because the full path might change at some point too if we change our install scheme or if we install updates and things like that. So it's always better to use the variable if it's set. So for example, if I was linking against netcdf, so I could do gcc my netcdf.c, and then for GCC, the way to tell it to search for libraries is with the -L. So I could do -L netcdf and then, the actual netcdf library or something like that. So again, these variables can be helpful. They're not always guaranteed to work. So sometimes you might have to do some additional things with the way you're building the software, but most things that are libraries will set something with the package name for the location. So you don't necessarily have to use the full path. zlib. Yeah, so again, there's also, we also provide zlib. So module AV, zlib is here. So again, if you load the module load zlib, and then do echo, and you can do actually module show. So the zlib package sets the zlib environment variable. So again, you can echo that. So you could use that variable in your build to point to that particular version of zlib. So, okay, let's go ahead and continue along here. So we're going to switch gears now and talk about Conda, and in particular Conda for, actually this should be in, I think, this way, data scientists. So any scientist or anybody that just likes to have fun can use Conda. So the lessons are online. So if you would please pull up those lessons to kind of follow along. I think that'll be easier. So this is the page. Let me try and put that link in the chat without exploding everything. There we go. So there's the link. We're not going to go all the way through these. We're probably going to just do up through lesson 4. The GPU stuff, that's tricky and that changes often. So for GPU things, there's some special magic there to get Conda to work for that, which is kind of beyond the scope of this. But if you have GPU packages that need Conda or that are available via Conda and you're having issues, feel free to email us and we'll try to help get that working. It can be a little bit tricky sometimes to get the versions right on that. So let's talk about Conda. So quick show of thumbs up or yes, who's heard of Conda or worked with Conda before? Okay, so it looks like just a few folks. Okay, that's okay. So I'll kind of start at the beginning here. So what is Conda and why should I care, right? So the way software is written in the modern day is that it's written in a modular fashion, right? So nobody, or at least anybody that's been around, will write their software and have the software do everything itself from start to finish. It's just not feasible. It takes too long. It's error prone. So modern software is developed using the concept of libraries or packages or modules. You'll kind of hear the words library and package used interchangeably, but basically what it means is that functionality is modular. So you might have a package that does nothing but write output files in a particular format. So if I'm writing software that wants to write files in that format, I'm not going to re-implement that in my own software. I'm going to use that library, right? So it saves me time. It's less error prone because I'm not writing something one-off by myself. I can take advantage of other people's work and contributions. So that's just the way it works, is that modern software is done in this modular fashion. And so things are broken up into libraries / packages. And so when you write something, you should look around first to see what is already out there that can do what you need. And so you don't reinvent the wheel for everything. Now there's some caveats to that. If the only thing you find is a package that, one guy wrote that hasn't been updated in 15 years, then yeah, maybe you want to just do it yourself, because things have changed, or that nobody's paying attention to it anymore, et cetera, et cetera. But certainly, I'm not going to write in my code, I'm not going to re-implement NumPy functionality. So NumPy is a numerical library for Python. It's one of the core scientific Python libraries. You would be bananas to re-implement stuff that NumPy already does, right? I just import NumPy, and I use NumPy, and I move on with life. So because that, so those are called dependencies. So when I write software that needs to do something that uses NumPy, NumPy is then a dependency of my software. So I need to have NumPy installed first, or have NumPy available in order for my software to work, right? So this can quickly get very complicated very fast. It's a what they call a directed acyclic graph, for those of you that are fans of graph theory. But essentially what it does is it defines dependency relationships, right? And it's even more complicated because packages change over time. So, NumPy 4 versions ago isn't the same necessarily as it is currently. So, things change inside the package. Functions that they used to provide, maybe they don't provide anymore, or more commonly, they add new functionality. So in those cases, your dependencies are even more complicated because you rely on a particular version or a range of versions. So for example, my software may only work with NumPy versions, 1.3 to 1.5, right? So before 1.3, it didn't have the function I use. After 1.5, they changed it, so it doesn't, no longer works the same. So my software can only use NumPy from 1.3 to 1.5, right? So, I mean, if you're literally only using a couple of things, you could probably just manage that manually, at least when you're working on your own machine and developing your software. But once you get to the point where you want to make that software available for other people, or more commonly, you're using a software that somebody else wrote, right? You don't necessarily want to have to mess with manually downloading and figuring out dependency relationships for, half a dozen plus software packages for something that you just want to install and use, right? You can do that. It's painful. Sometimes that's the only choice, but Conda came along and tries to make your life easier. So package managers. So Conda is what's called a package manager or environment manager. Those aren't new. Those aren't new things by any means. So if you're familiar at all with Linux, you might have heard something called RPM, or Yum if you deal with CentOS-based things, or apt if you deal with Debian/Ubuntu type things. But up until fairly recently, package managers were intended for sysadmins to use to configure the system software. So they require root to run. They have specific limitations, so it's typically hard to install multiple versions simultaneously. So if I'm using the system-wide package manager and I want to install both Python 3.4 and 3.5, that can be hard. And that's not really what they were intended to do. They're intended for a systems administrator to manage the software on the system, and have things be stable, have upgrades that are relatively painless, that kind of thing. So for a scientist, that's not the best solution. If I'm working alone on my machine that I control, that I have root access on, I can do that. I can use apt or Yum to install things. And it'll probably mostly work until you get into cases where you need multiple versions, or there's conflicts and things like that. And then it can be kind of a mess pretty quickly. So Conda came along and is trying to solve that problem for a normal user. So somebody that doesn't have root access on a system, somebody that's a scientist, or a researcher or a programmer, not somebody that's a sysadmin. So what Conda lets you do is it lets you create segregated, separated environments where each environment is a standalone thing. So if I have a particular package that needs a particular set of dependencies, I can create an environment that has those things installed, but is self-contained and isolated. And then if I have another package that has a different set, I can create a separate environment that it has the requirements for that package, and those two things don't interact. But they're separate. I use one or the other at a time. I can make changes in one without affecting the other. I can make changes without affecting the system-wide software. And that's an important bit, because obviously on a shared environment like a cluster, we obviously don't allow root access or anything like that for users for obvious reasons, right? That would be not feasible. So Conda provides a way for you as a user to manage software and to create environments. So Conda has this term environment that you'll hear a lot. And what that basically means is a self-contained system where I have my application and whatever requirements that it needs. And it's a standalone thing. It doesn't interact with the system level software. I can create multiples of those and I can have them next to each other and they don't interact. So it's a great way to manage stuff for scientific software. So Conda is not the first to do this. There have been other environment management systems. So if you work with Python, you might be familiar with something called virtual env or VENV. That was devised, again, as a way to solve sort of the same problem, but for Python in particular. So with virtual env, I can create standalone Python environments that don't interact with each other, and again, install whatever I need to in those environments. The limitation typically has been that these things most of the time have only worked for a single language or a single software system. So virtual env works for Python, but not necessarily other stuff. And so that could be hard because a lot of times I have a Python package, but it might depend on a C library, a compiled C library. So for example, NumPy itself, a lot of what it does is done as compiled C libraries because it's faster. So Conda came along and tried to solve that question. So one of the things that people often get confused about is that Conda is not meant just for Python. Okay, Conda is written in Python, but it's not meant just for Python packages. It can manage R packages, it can manage Perl packages, it can manage essentially any type of software that can be installed and packaged up. So it's what they call language agnostic, or they call it an agnostic package manager, in the sense that it doesn't really care about what language or what type of code it's packaging up. Certainly for particular languages, it can do more things, so the way Python packages are handled, it's smart enough to know about some of these languages. So it's smart enough to understand when it's packaging up a Python package, and it can take some shortcuts and do some fancy things. But generally speaking, you can package up any type of software with Conda. So what does a good package management system do? Basically, it figures out what the compatible versions and dependencies of things are, and it installs those, and it handles the process of updating that stuff such as not to break what you're already using, right? So if a particular software can, so again, if my package can only use NumPy 1.5 at the newest, if NumPy 1.6 comes out, I don't want my package manager to automatically update that, right? Because it will break my stuff. So it has to be able to understand version requirements and things like that in order to keep stuff sane, keep stuff functional. So again, so Conda does both. Conda does both environment management and package management. And again, there are systems that have done both of those already. Pip is a package manager for Python. So if you worked at all with Python, you're probably familiar with Pip. But there are certainly others. But Conda does both handle the environment and it handles the package management. So why should I use that? Well, installing software is hard, right? I spend a good percentage of my time doing that. So I can speak from firsthand experience. And again, it can be quite difficult at times to get things to play together. So you may have a software that requires half a dozen dependencies. Each one of those things has its own requirements, of course, right? So it's a tree all the way down. And then they have specific version requirements. And so getting the versions of everything just right to get the thing to work, if you're doing it manually, it can be a nightmare in some cases, right? And you as a scientist or even as a programmer necessarily, you don't care about that. You just want stuff to work, right? I want to do Conda install PyTorch, and I want it to work, right? I don't want to have to worry about specific versions and all that kind of stuff. So that's what Conda tries to solve. Conda is trying to make your life easier. So that's really one, the potential benefit for you as the scientist or the researcher is to make some of these things just go away, right? So question here, what are some of the potential benefits from installing software separately? What are some of the potential costs? Anybody want to chime in on that? Feel free to unmute or put a answer in the chat. Space. So yes. Was that a benefit or a cost? Cost, exactly. Right. So the way Conda does things, at least on the surface, is it creates, again, parallel environments, right? So if I'm installing NumPy in each one of those environments, in theory, if I have X environments with NumPy installed, I'm using X times whatever the space requirement for NumPy is. Now, because the people that write these things are smart, they do some shortcuts to try and avoid that. So they will do what's called hard linking or soft linking, which is a file system trick to avoid using double the space. So I have to pay the space penalty once for NumPy for a particular version, a particular build. But if I'm using that in multiple environments, I don't pay that cost every time, at least by default. There are some cases where that's necessary, but generally speaking, Conda tries to be smart and tries to avoid, exploding space requirements. So benefits, protection that separate projects, well, exactly, right? So I can keep these things, I can keep my separate projects isolated from each other, so I can make changes in one and it won't affect the other. If I'm doing things system-wide, if I upgrade Python system-wide, well, guess what? Everything that used Python on that system has now been changed in theory, because there's a different version of Python that's present. So with Conda, I can keep those things separate. Yep, and so that's essentially the answer, or some of the answer anyway. So using Conda solves two different things, right? It solves my environment management problem and it solves my package management problem. So we'll talk a little bit just about the differences. So there's some terms out there that can sometimes be confusing. So you'll hear the word Conda, you'll hear the word mini Conda, and you'll hear the word Anaconda. So Conda is the package management, environment management tool itself. So when I run Conda, I'm running the tool that does this environment management and does this package management. Mini Conda is the Conda tool packaged along with a version of Python and a few very essential packages. So it's a small install that includes Conda plus a handful of other things, essentially just to ensure that Conda can work. And then from there on out, I can create whatever environment I want to using mini Conda as a base. Anaconda is the full distribution, is mini Conda plus a bunch of packages that are deemed useful. So when I install Anaconda, I get NumPy, I get SciPy, I get Matplotlib, I get a bunch of other things that are sort of the standard scientific Python stack. So depending on what you want to do, you'll either install mini Conda or Anaconda, probably Anaconda to start with, unless you have a specific use case where you don't need all that other stuff. So HCC provides Anaconda, module load Anaconda essentially. So it's already installed on HCC. You don't have to install it for yourself. You certainly can if you want to, but there's not a lot of point necessarily in installing it for yourself, because again, with Conda, you can create whatever environment you want using Anaconda or Mini Conda as a starting point. The particular Python version that Anaconda is installed with does not limit what other versions you can create environments with. So if the version that it's installed with is 3.8, I can create 3.9 environments. I can create 3.7 environments. It doesn't matter. So again, I hope I've motivated enough to convince you why you should look into using Conda if you're doing things. It takes it, you know, the goal is to take a lot of the headache out of things. It's not perfect. No, nothing is. It has issues, but by and large, it will hopefully make your life easier. Okay, let's go ahead and what do you think? Good time for a break? We've been going a while. Emily, Narukha, anybody think a good time for a break?
Yep,
Let's take a break.
I agree.
Let's take a break. 10-minute break. Go refill your coffee or whatever, and then we'll come back and we'll start actually doing some things. So take the advantage in the break to make sure that you're logged in to Crane, and that you can, you know, you're at your terminal there and you're logged in, and then we'll start doing some more interactive stuff after the break. So come back at 2:40. Thanks, guys. Okay, let's pick it back up. Hopefully everybody has a fresh cup of coffee or tea or whatever else you prefer. So let me go back to my lessons here. So at this point, we're going to actually start doing some hands-on stuff. So again, if you have questions about what we're doing, you know, feel free to put it in the chat or even just speak up since it's such a small group. So I'm going to go back to my terminal. Can everyone, is the font big enough? Everybody see that okay again? If you can't, please holler. So the first thing I'm going to do is I'm going to use module, and I'm going to run module purge. And that's just to clean everything and make sure we start with a clean environment. That's, you know, it's a good practice when you're doing things to run module purge first and then only explicitly load what you want. It ensures you have more of a repeatable environment and things like that. So if I run module list, nothing loaded, excuse me. So to start with, I want to do module load Anaconda. So now I do module list and I have Anaconda 4.9 loaded. I think there might be one slightly newer version, but that's close enough for our purposes. So in the lessons, when it talks about installing and using the base environment, you can basically just read that as having loaded the Anaconda module. So when you load the Anaconda module, think of that as having just installed Conda, and you have essentially a blank slate, you know, a blank install. You don't have any other environments or anything like that. So the first thing we want to do is create a little directory here to do all of our shenanigans in. So I'm going to do mkdir introduction, and then it's a ridiculously long folder name. Do Conda for data scientists. Yes, okay. Okay, and then I'm going to cd into that directory. So if you haven't been included into the tab complete trick, learn it now and love it. So if I start typing IN and I hit the tab key, it's going to autocomplete that for me, so I don't have to type the whole bloody thing out. If there's more than one folder that has the same characters, you'll have to keep typing essentially until it gets unique. But once it's a unique thing, it'll just autocomplete it for you. And then I'm in the folder, so there's nothing here since we just created it. So let's create our first environment. So a good practice is to avoid installing things in your base environment. So when you're working, you know, on your laptop, after you install Conda, you'll have the first environment that it creates is its own, and they call it base as the convention. So it's best practice not to install stuff in that. It's always best practice to create an environment for everything you're going to do. And that just avoids issues moving forward. So the first thing we want to do is we want to create an environment. So Conda create, and we're going to give it a name. So -- name, and we're going to call it Python 3-env. I'm going to make my terminal a little bit larger here. And then, so that's the name. So the next, what we want to do after that is provided a list of packages we want it to install when it creates the environment. So I'm just going to say Python, right? So this can be as specific or as generic as you like. If you don't give it a version number, it's going to essentially default to the latest. So hopefully everybody's following along and has this typed out. And let's go ahead and just hit enter and see what happens. So you'll see the nifty little thing spin. Okay, so in this case, it's defaulting to Python 3.9.5. Okay, because that's the latest available. But let's not do this. Let's hit no. So we want to stop this for a second. So it's generally speaking best practice to specify a version number. That helps for repeatability. It also helps to make the environment creation a little less painless. So in this case, let's go back up. So we're going to do Python equals 3.6 this time. Okay. So now if I hit enter again, now we can see that it's going to create Python, in this case, 3.6.13. So it's going to essentially give us the latest version that is available in the Python 3.6 series, right? So if I run this command 2 months later, it might be 3.6.14. Again, Python is pretty well behaved, so it doesn't so much matter that last digit. But if you really want to get very specific, so let's cancel out of that, hit no. So if I want to get very, very specific, I can say Python 3.6.13. And again, it's going to use that version, right? So you can get pretty specific with these version numbers. That's not necessarily always needed. You know, if you're using a particular, what they call a major version of Python, so, you know, Python 3.6, 3.7, you can just do that and it'll be fine, usually. Okay. So I can do more than one, right? I don't have to just specify a single package. But let's do one thing first, and let's learn how to search a little bit. So Conda has a search command, which is handy. So let's see, I want to look for the package called scikit-learn. So if you're doing any kind of machine learning, you're probably familiar with scikit-learn. So let's do Conda search scikit-learn, and it might take a couple of seconds here because there's probably a lot of versions of scikit-learn. So one other trick to reduce the search time is you can also give a version number to the search. So if you know you're just looking for scikit-learn, I'm not familiar with the version numbers offhand, but let's say 1.2. I can also do Conda search scikit-learn equals 1.2, and that will only return versions that satisfy that constraint. So as you can see, it took a little bit because there's so many of these things available, but it goes all the way back to 0.17.1 and up to, I think the latest is 24.2 now. Okay. Any questions about that so far. So again, I can do multiple versions here when multiple packages when I create this environment. So for example, I could do matplotlib equals 3.1. Oops. So if I want Python 3.6 and matplotlib 3.1, I can just separate them by a space. And so obviously, so Conda is not only going to install those packages, it's also going to install all the packages that are required for those packages, right? So it's doing this, what they call dependency resolution, which is a fancy term for figuring out what needs what, right? So it will take care of that all for you behind the scenes, and it will do that in a way that it doesn't really matter, such as it satisfies the requirements you gave it of Python 3.6 and matplotlib 3.1. Okay. Okay, so let's do a little exercise here. Let's create an environment called machine learning env, and we want to use the most current versions of IPython, matplotlib, pandas, Mamba, and scikit-learn. So that's kind of a long list. Let's go back here. So it's this exercise here. So let's go ahead and do that. I'll give you a few minutes to do that. And again, if you have issues, click your red reaction thingy. And if you get done, please go ahead and do the green one so we know where folks at. So there's a couple of ways you can do this. You can run the search command to find the most current versions of each one of those things, and you can give that as a version number. Or again, if you don't specify a version, Conda will default to the latest. So there's two different ways to do that. So it's up to you what you want to do. But let's go ahead and take, what do you think, 5 or 6 minutes to do that? And then we'll come back and I'll work through the solution and actually show it to you. But hopefully everybody can get that done here in the next couple of minutes. So it's Conda search also. Yes. So again, Conda isn't limited to Python packages, so it can search for other types of packages. So I mean, it treats all the packages sort of equally by the name. So by convention, the R packages are all prefixed with R dash and then the name. But you can, give me an example of an R package. ggplot2 or whatever, right? So the Conda package name is probably r-ggplot2, but you can search. So Conda search allows wildcards. So if I do Conda search ggplot2 and it doesn't find a package that has that name specifically, it's going to go ahead and search for that as a wildcard. So anything that will have that in the name. I can also explicitly do that using the star, the asterisk, like you do for Linux, standard Linux wildcard. So I could do Conda search asterisk ggplot2, and it will look up anything with that in the name. So yes, so it works for other things. Is a short answer to your question. So okay, let's take a couple minutes and do that, and we'll come back here in a few minutes. Okay, again, if you're done, please put up click your green check mark, and if you're having errors, if something's going wrong, hit the red. If you just need more time, that's okay. We can take a couple of more minutes. Looks like there's a question in the chat. Where is this actually installing packages? Yeah, so good question. So if you've installed Conda local, if you installed Conda on your laptop, it's going to put these by default. It's going to put these environments by default in an environment subdirectory of wherever you installed Conda. On Crane, on HCC machines, because no errors, but yeah, so that's, yeah. So you've probably run into one of the limitations of Conda pretty early here, and I'll talk about that in a bit here. But because we're using this on Crane, where it's a multi-user install, in other words, you don't have write permissions to the main Conda install location. So Conda in this is smart enough to realize this, and so it's going to put these environments in your home directory. So there's going to be a .conda folder in your home directory, and under that there will be an environment or an envs directory, and that's where those will actually go. And it will show that when it actually creates the environment. But by default on HCC machines, that's where those are going to go. You can change that. We'll do a demo of that in a bit. So there might be some times where you want to put those environments in a different place, but by default, it's going to stick them in a .conda directory in your home folder. Okay, let's let me just go ahead and demo this because it might take a few minutes again for the thing to actually spin through and do this. So the solution here, you could do it a couple of ways. You could simply do the names, and in that case, it's going to grab whatever latest versions there are and use those. A better practice is to, again, specify these version numbers. That does a couple of things. It ensures that it's a more repeatable thing, and it also will probably cut down the time it takes Conda to actually install the things and create the environment, because you're giving it more specifics. So let me go ahead and just copy those lines. So these version numbers are probably out of date at this point. So what you would want to do if you were doing this sort of for real is you could use the search command to search for each one of those packages, and then whatever that latest version is, you would specify that version number. So let me do, let me see if I can just get away with copying, pasting this. Hey, I think it might work. So in this case, we're giving the specific versions. And you might notice that this takes a while. One of the major complaints with Conda is that it can be slow sometimes. Oh, Mamba isn't available. Okay. Well, all right. So I said there were going to be hiccups, and by golly, there are. So let's do Conda search Mamba and find out a different version. Okay. So I wonder, was that? Oh, 51. There was a I didn't quite copy it. Okay, that's my fault. Sorry about that. So again, for large or complex environments, Conda can sometimes be a little slow. We'll talk about ways to mitigate that. But specifying the versions really helps with that. So it will really cut down the time it takes to create these environments. So, okay, so for example, so here, like I said, it prints where it actually puts it. So in this case, the environment location is inside this .conda directory in your home directory, envs, and then the name of the environment. A good practice is to append -env to everything. That helps you kind of keep things straight. It also helps in cases where you're putting these folders someplace else. So there's nothing necessarily special about this .conda/envs folder. That's just the default location. I can create these things anywhere. And as far as the operating system is concerned, it's just a folder, so it doesn't really matter. But if you're putting these things in other places, it can be helpful to append -env or -conda or something that that it's a Conda environment, and that's just for your sanity. So here's everything that's going to actually install. So as you can see, it gets to be pretty complex, pretty fast, and woe be to you that would try to figure this out by hand. So it's going to ask me to proceed. So I hit yes, and now it's actually going to download these things. And again, by default, it's going to store stuff, the actual downloaded packages in this .conda directory. Actually, I take that back. I'm sorry. On HCC, we actually point that to work. for space reasons. So it will actually put those things in your work directory. So again, it can take a few minutes here to spin through and do these things, depending on how big the packages are. Is everybody at least to the point where it's doing something? I mean, there's nobody seeing hard errors or anything. Again, if you're having issues, please ping somebody in the chat. Seems stuck execute. Yeah, it might take a little bit. Part of the reason for this is that the home directories are not very high performance. So the type of things that Conda does when it installs can be pretty hard on a shared folder like home. Typically things on your desktop, especially if you have an SSD, then it should be pretty fast. So just have to have a little bit of patience here on the clusters, just because of the way the home directory works. Any other questions while we're waiting for computers to do your thing? Is your environment available on all 3 volumes? Not quite sure what you're asking. So the environment is installed in your home directory, but because the home directory is available on all the cluster nodes, you can use it from any of the nodes. And basically, you can use it from within a job, no problem. On different clusters, that's a different issue. So again, home and work are only per cluster. So if you're working on Rhino, something that you've installed in home on Crane isn't going to be there. You would have to either install it again, or we'll do a demo here. You can actually install it in common, and then that environment would be available on both machines. Interactive shell would require you to load modules separately, I assume. Yeah, so when you run an interactive, you're talking about an interactive job? Okay, yeah, so when you run an interactive job, the job is going to inherit whatever you have loaded. So if you just have the default modules loaded, that's what it's going to have when the job runs. If you do a module purge and a module load Anaconda, then your interactive job will have Anaconda loaded. So by default, it inherits whatever you have in your shell from the login node. There's ways to change that if you want to, but that's the default behavior. Okay. Yeah, it's kind of a long package list here. I should have done maybe just a smaller number of packages here, but so if this seems like it's taking a while, just compare this to installing everything manually, and you'll be thankful that you're doing it this way. Okay, making progress. See a couple of people with green check marks. Does that mean it actually finished all the way through? Hopefully. Is everybody else just at the verifying or executing stage? Okay. So this seems like a good place to do a sidebar. Let me, oh, we got a question. Similar to module look at. So similar to the load module command, do we need to do any command to load specific? Yes. So we're gonna talk about that as soon as this finishes. Conda has a command called Conda activate, which will activate. And you can't see it, but I'm doing the air quotes, which will activate the environment and make it ready to use. So yes, as soon as this finishes, we'll do that and we'll demo that. So this seems like a good place for a sidebar. So let me do that real quick since it's taking a while. So I want to talk about something called Mamba. Climate model. Different environment. Okay, sorry, I had another question in the chat. Created in different environment. Said created an environment for running NCAR's climate model. But I'm still skeptical about it working. Yeah. Yes. So Conda, something that Conda doesn't handle very well is MPI. That's kind of its big weakness at the moment. So for things that are single-threaded or multi-threaded, it usually works just fine. For things that are MPI based, it can be a little trickier. But it's some of the NCAR, some of the dependent packages for things like WRF and things, they actually use Conda now as their recommended distribution. So I think like NCL, they recommend just using Conda to install it. So I would be cautiously optimistic, I guess, that it would work. It's certainly worth a try, right? As you said, it can potentially save you weeks of work. Even if it only partially works, that might still save you effort. So let me see how this is doing. Okay, it's still spinning. So let me talk about Conda env list. Yes. So that's the comment is Conda env list is giving me a lot more things than I'm expecting. Yes. So that's a consequence of the way HCC does some things. So we use Conda envs behind the scenes for a lot of things. So a lot of the software installs are actually done using Conda environments. And so it's Conda is finding those and listing those for you. So yes, it will potentially list a lot more things than you would normally expect. So let me finish my thought here about Mamba while this is spinning. So we're seeing that one of the major complaints about Conda is it can be very slow when it's doing environments that are large or complex with lots of packages or dependencies. Again, part of the reason for this is that it's running on the cluster where the home file server, isn't super fast. So that's taking a while. But the way Conda is written, that's a weakness. And so that's if you Google Conda complaints, this is something that you'll find at the very top of the list. So there's a project called Mamba, a software called Mamba that aims to help with this. So it's essentially a modified version of Conda that uses a different solving engine. So Conda itself is purely Python based, but this Mamba project, it uses a C++ based library that is actually used in the operating system package managers like apt or dpackage. And so because it's using a different library, it can very, very greatly speed up things. So HCC has that installed, module load Mamba instead of module. So you basically do module load Mamba instead of module load Conda, or Anaconda, excuse me. You still use the Conda command to activate and deactivate the environment, which I'll demo here in a second, but you essentially use Mamba for everything else. So it's essentially a drop-in replacement for Conda. So if I, instead of doing Conda create, I do Mamba create. Instead of doing Conda install, I do Mamba install. And it will typically be, for simple environments, it may not be that much faster, but once you get into complex things, the difference in the speed can be quite startling because it's using a different library and it's also multi-threaded for those of you that know a bit about parallel stuff. So let's go back to my terminal. Boy, that is still chunking along, isn't it? Okay. So maybe this is a good place to demo that instead. Let's do that. Let me try that. So Control C, and hopefully this will work. So let me see. Did anybody, if you've gotten all the way through and it's actually created that, go ahead and do your green check mark, or is it still spinning for a lot of folks? A few check marks. Okay. Let's see if I can cancel this. There we go. Okay. Fine. They're gonna let me kill it. Come on. So sorry for the hiccup, folks. Again, this is the first time we've kind of done these lessons. So please bear with this here as we have some issues. Okay, so we're back to our prompt. Let me just do a little bit of cleanup here just in case. Okay, good. So let's try Mamba instead. Nothing like real world problems to to show how to do stuff, right? So I'm going to do module purge. I'm going to do module load Mamba. You can try doing Control C, or you can just let it go. It's up to you. But I'm going to keep going here with the demo just for time's sake. So again, Mamba is essentially a drop-in replacement. So I'm going to go back up to my Conda create command, and I'm going to do Mamba instead. And you'll see it. Oops, let me delete that directory. Just clean that directory up so there's no issues here. Just delete the whole thing. Go back to scratch. Okay, so Mamba create, and it prints an obnoxiously large banner. But other than that, it works pretty well. So the output's a little different, but it's essentially doing the same thing. It's taking what you specified and trying to create an environment. Let's see if we get. Okay, so it's giving me a list of packages. I hit yes, just like I did before. So it's faster. It's not instant. It's still a fairly complex environment. You can see how many packages it has to install. So it has to figure out, compatible versions and all that kind of stuff. Are things still spinning for folks that did Conda, or is it? So if it's still spinning, go ahead and put the red X up. Okay, let me just keep talking through some of the material here while this goes, and hopefully it'll catch up. So once we create the environment, we have to do what's called activate it. And what that really means is it's basically adding some things to the path environment variable. That variable holds the list of directories that Linux will search for programs. So that's one of the things that modules also do is modify this path. And then it will run what are called activation scripts. So some packages may need some other environment variables set. It may need some, initialization steps or something. So these activation scripts are ways to do that. Most packages don't have any. Most packages really all it's doing is setting the path. But if I want to use that environment, then I need to run Conda activate. So when I'm doing a job script, if I want to use a Conda environment instead of a module, what I basically do is I would run, so in my job script, I would do module purge first just to make sure everything's clean. I would do module load either Anaconda or Mamba, and then I do Conda activate, my environment, right? And then that environment is available to be used in any subsequent commands I have in my job script. Okay. So if I want to deactivate, I basically run Conda deactivate, and what that means is it undoes the changes that did up here when I activated it. So Conda is designed so that only one environment really can be active at a time. So that's the separation or the segregation that it does for the environments. So that's how it keeps things from interacting with each other. So really only one environment can be activated at a time. So if you have, a bunch of things that you need to use at once, you would create an environment with everything in it and do it that way. If you have things that can be used separately, you can Conda activate env1, Conda deactivate, Conda activate env2. I believe Mamba's having issues. Okay. Well, I'll tell you what, just for the sake of sanity, I'll just create an environment with simpler stuff. It should be faster. Sometimes there are packages that are bad. They have, there's some issue with them, and that can cause issues with Conda trying to do the solving. So it's possible that's happening. Let's see, what did I say here? Machine learning environment. Swap over to this and cross our fingers. So I'm just creating creating an environment, but I'm just giving it IPython and Python. So much smaller set of packages here. Although more than you would think. If you're still having issues, if it still hasn't finished, go ahead and please ping one of the staff folks, and they'll try to help you with canceling it and creating just a simple environment. There we go. Hallelujah. Okay. So, okay. So again, to activate it, we do Conda activate. Learning ENV. Okay. And you can see that it actually changed the prompt. So when you activate an environment, by default, it will change the prompt to include the name of the environment, and that's just to help you to remember that it's active, right? So right now, if I want to, so right now I can use this environment, right? So if I run the Python command, so which is a Linux command that will print the full path to another command. So if I do which Python, it's going to tell me what command actually gets run if I just type Python and hit enter, right? So in this case, it's showing that, yep, it's actually using the Python that's installed in my machine learning ENV environment. So Python 3.8, which is the same, exactly what it installed. So now I'm using my environment. Okay. So exit out of Python. Oops. It's a function. So again, I can deactivate the environment. So I do conda deactivate. All right, and then the prompt changes back. So let's reactivate it for the next issue, for the next thing. So I've created my environment, but it's often the case that I don't know everything I want ahead of time, right? So I don't necessarily know every package that I need to specify on the conda create command. So if I want to install additional packages, then that's where the install command comes in, obviously. So after I've activated the environment, I can run Mamba or Conda. You can kind of use these interchangeably. And let's see, for example here, they say Mamba. So let's do Mamba install Mamba. And because I didn't give it a version, it's going to pull the latest. It's going to try to pull the latest, right? So in this case, it's 0.53.1. Is everybody at some point where you can actually run Conda or Mamba install? If you're still having issues, again, please message somebody or let us know somehow. So I'd like to be able to you'd be able to follow along with these at this point. So. Okay, so package is installed. So I can run the conda list command, and that will show me what I have installed in my environment. So if I run conda list, it's going to tell me here are the packages in this environment, and it lists them all, obviously. see, we've already talked about where it lives. So again, for the install command, I can give it specific versions. So if I want to do Mamba install, I'll go back to using Conda here and cross our fingers. Conda install scikit learn. I'm going to give it a version 0.22. So I can use Conda and Mamba interchangeably here, but just because I've created the environment with Mamba doesn't mean I can't use Conda to install other packages. So that's kind of a neat point. Do we need to reinstall Conda every time when we connect to HCC again? No, so Conda is installed. Again, it's just as Colin noted, you just need to load either the Anaconda or the Mamba module each time if you want to use it. And then if you have an existing environment, you just do the activate. So let me just hit yes here. So if I logged out and logged back in, all I would need to do to use this environment would be module load Anaconda, Conda activate, machine learning env, right? So environments are persistent. You don't reinstall things every time. Okay, so it's installing. And again, it will essentially choose the latest version that satisfies this number, right? So in this case, it's doing 0.22.1. If I ran this command 2 months from now, it might do 0.22.2. But generally speaking, those last digits don't matter so much. Each account system's environment will not be reset when user logs out. Not quite sure I know what you mean there. So again, by default, the modules that you have loaded in your session, those don't persist across sessions. So if you have the Anaconda module loaded, if you log out, log back in, what you're going to see is the default set of modules that we load. You would still have to load the Anaconda module again, but you don't have to recreate the environment every time. Okay, great. Thank you. Okay, so we can do a slightly different way to install packages. So I'm going to deactivate this environment. So one way to install packages in a specific environment is to activate that environment first, but I don't have to. I can give a name option. So I can do conda install -- name machine learning env, and in this case, I think the example is to do dask. So you can see it's installed, even though I don't have the environment activated, because I gave it the name option, it's installing it in that environment. So go ahead and hit yes. So essentially 2 different ways to do the same thing. It's just a convenience thing, whichever is more convenient for you. Okay, so we talked about where Conda environments live by default, but they don't have to. So again, there's nothing inherently special about that directory, that .conda/env's directory, other than it's a default path that Conda searches for environments. Okay, but I can certainly specify any directory that I want. Okay, so let's do that for an example. So as soon as this finishes. Is everyone sort of caught up to this point where we're able to actually follow along now? I hope. Okay. Again, if you're having problems, put up hit the red button or message someone or in the chat is fine too. Okay, so I'm gonna make that directory again. Let's see what the name of that thing was. I'll make it a shorter name. Okay. So let's look at putting an environment in a specific place. So in this case, I'm in this intro to Conda directory. Okay, so the typical use case for this is that you're working on a project and you want to keep sort of everything self-contained within one folder at the top. So you might have your code in this folder, and you want to have your Conda environment in this folder as well. And that way everything's self-contained and the Conda environment is not off somewhere else. It's just easier usually, so it's a sanity thing. So to do that, Conda has a -- prefix or -p option for short. So I can do Conda create -- prefix, and then I give it a path. So in this case, I'm going to do /env, which means the current folder. So I want to create a folder named env in the current folder, and that's going to be my Conda environment. So again, let's just give it a simple requirement this time for the sake of speed. Let's say matplotlib 3.1. So hopefully this won't take terribly long. Any questions, issues, problems? So naming convention, Conda doesn't care beans what the folder is named. For your own sanity, again, it's probably good to prefix things with a dash, or excuse me, put a -env suffix on things or whatever, right? As long as it's consistent for you and you know what it means, Conda doesn't really care. How would you delete, remove an individual package? Okay, great question. So we'll show that here in a sec, as soon as this finishes. Command to install a package in an environment. Yeah, so we did that a little bit before. So that's just Conda install. So if I have my environment activated, I can do Conda install and then the package name and optionally a version number. And again, if I don't have my environment activated, I can use the -- name option. So in this case here, I don't have the environment active, but I give the -- name with the environment name and again a package name, and it will do that. Did that answer your question? Okay, great, thank you. Oh, it needs Qt, okay. Okay, I actually have the other one finished, so I'll answer your question about removing, deleting while this thing goes. So we'll go back to this one. So this is the other one we did earlier, but doesn't really matter. So if I want to uninstall a package, I can do that with Conda remove, and I think they also support Uninstall, yeah. So Conda remove or uninstall, they do the same thing. So let's take a look and find an unwitting package here to uninstall. So one thing to keep in mind, right, is dependencies. So if I uninstall a package that other packages depend on, it's going to uninstall those other things too, right, because they can't work anymore. So let's try and find something. Let's just pick JPEG. So Conda remove JPEG. Give that a second. There are ways to override that behavior. So you can give it an option to not uninstall the dependencies of a package. You're taking your life in your hands at that point, right? Things might not work, but it's possible. It's a fairly advanced thing. There might be reasons for doing that. Okay, so in this case, it turns out that a lot of stuff needs that JPEG package, right? So it's going to remove all this other stuff. So I can do that, but maybe not. So let me cancel that. I was hoping I could find something that would be fairly simple here, but try PCRE. So one other default behavior to be aware of is that Conda really likes to try to upgrade stuff when it can. So if you're installing things, it may or will likely upgrade other stuff. Okay, so I can actually do that. Oh boy, that okay. Well, so PCRE needs a lot of stuff too, right? But I can do it. So Conda has an option called freeze installed, -- freeze -- installed. So if you're seeing things that get updated when you don't want them to, you can use that option and it will not automatically upgrade other stuff. Okay. The question, thinking about space, my env is getting pretty big. I assume remove that, but yes. So asking about removing the environment, does that also free up the space? Yes, but so it will remove the space that the environment is using, but it won't necessarily free up the space that the downloaded packages use. Okay, so Conda downloads the packages. That, again, not by default on HCC is in work. So that's, we put those in work for sanity purposes. But there's a command, there's a Conda clean command. So it's Conda clean. So if you really want to clean up everything, you can do Conda clean -- all. That won't remove any environments or any packages that are being used. But if you have a bunch of packages that were used in environments that no longer exist and are there taking up space, that will clean those up. Okay, so we've created this environment in a custom location, right? So we've created an env folder in this intro to Conda folder. Make this go away. So if you'll notice, the Conda activate command is a bit different. So now it gives us the full path. So because it's in a custom location, that's the difference. So when we created it in the default location, Conda knows to look there by default. So all you got to do is give it the name. But if the environment is in a custom location, you have to give it the full path. So I'm going to do Conda activate home demo 21 intro to Conda /env. So you'll notice that it did that. One of the sort of minor things that it will do when you do an environment in a custom location like that is it's gonna, instead of just the name here, it's gonna do the full path. So depending on where that is, that can be a bit annoying. There's a way around that. You can use a Conda config command. So let me activate. So Conda config, that's the command to change configuration options. There are a ton of them. If you Google, Conda config, you'll find the big list. But one of the options is to override the default prompt behavior. So I can do that this way. And so name is just a placeholder for whatever the name of the environment is. So now if I run Conda activate, right? So now it's only showing the name, not the full path. It's up to you. Sometimes it's less confusing to have the full path. Sometimes it's more annoying. So it's just an option. Lots of things have config variables or config options that will change their behavior. So if something isn't doing quite what you want, look up the Conda config page and see if there's a way to change it. Okay, so Conda deactivate. One other option is if I'm in this directory, I can do things using relative paths. So I can do Conda activate /env, right? And then it's activated that env. So that's a little bit of a shortcut. You can do things that way. You don't necessarily have to give it the full path if you're comfortable with relative paths. Intro to Conda /env. So right, so I'm giving it the relative path now, and Conda is smart enough to figure that out. So if I do which Python, yep, it's using the Python in my environment that I created there. I think we won't go through the R example, but I will talk about it. So again, Conda is agnostic in terms of really what kind of packages it can manage. So it can do R as well. So I can create environments that are R-based instead. So let me deactivate this. So if I want to, I can create an environment, like my R or whatever. The base, so again, the naming convention for R packages is R - something with the package name. So the base R install is just called R base. So that just gets me R. If I want other things, I can do, R - tidyverse, right? And again, I can give it a version number. So let's say 4.0. Oops. We create. We won't let this go all the way through for time purposes, but hopefully it will show you what it's going to do. Right, so it's installing R base 4.0.5. It's installing R tidyverse. So if you're not an R wizard, tidyverse is basically just a collection of other packages that are useful. So because of that, it's pulling in a bunch of stuff. But if you're an R person, you should recognize these names. So the naming convention is really the only hard part here. Is you just got to know that things are named R - whatever the R package name is then. And again, here, Conda search is your friend. Okay, so listing environments. So I think someone did that up in the chat, but Conda env. That's a command that you can use to manage the environments. So one of the things you can do is list. So in this case, it's printing the ones that I have in my home directory, right? Depending on how you run this and what other modules you have loaded, you might see other things listed. And again, that's a consequence of the way HCC manages our software. We use Conda environments for a lot of things. So when you're loading a module, what you're really doing is activating a Conda environment. That makes things easier for us to manage, so that the same benefits that you see as a researcher, we see as folks trying to manage the software, right? There's some other advantages to that, because it makes it easy to copy environments. So one of the things Conda can do real easily is clone, what's called clone an environment. So if you want to, so for example, HCC provides a package, but you need some other things, or you need to customize that a little bit. If the package is done as a Conda environment, which a lot of them are, you can just clone that environment. It will create a local copy for you in your home directory. Then you can make whatever changes to that you want. But it's a way to get a sort of a pre-canned starting point. That's really useful for the GPU stuff. Again, as I mentioned, getting GPU things straight can be an issue. So one of the things we recommend, and it's actually in our documentation. Pull up the docs page for that. So creating custom GPU environments. So we provide several packages that are GPU enabled. But again, just because of the sheer breadth of the software, we can't provide everything with every version and every variant that people need. So one way to get around that is to clone the environment that we provide for the GPU package. That gets you a working install. And then you can make whatever further customizations you want, because it's a local Conda environment then that you have write permissions to. Let's see where we were at here. Okay, so I showed it a little bit before, but we can do it again. So if we want to list the contents of the environment, we do Conda list. If the environment is active, it will print the contents of that environment by default. But I can also give it a path, right? So I can do prefix env, and it's going to print the contents of that environment that I passed to it. Okay. Okay, so deleting. So there's a couple of different ways to delete environments. You can use the Conda remove command, or you can also use the Conda env command. The remove command was first. They actually added the env command later to make some things easier. So there's a little bit of overlapping functionality there. I believe they recommend using env now, but since I've been using it for a while, I still muscle memory back to remove. So if I want to remove everything, I can do Conda remove. And because it's, okay, so let's look here. So again, it depends on where the environment is, right? So if it's an environment that's in my Conda envs directory, I use the name option. So Conda remove name machine learning, oops, env, and then I give it the special -- all option, right? So Conda remove, by default, it removes individual packages, right? But I can give it this all option. So if I do that, it's going to say removing all packages. And once it does that, the environment will no longer be there. I'm going to hit no on this so I can show the other option. So the other way is to use the Conda env command. So env, if I run -h for help, you can see there's a remove command. So I can do Conda env remove. And again, it's the same thing with -name. So machine learning env. And so it's going to do the same thing, but it's just usually a little bit easier to use the env. And it doesn't actually prompt, so that actually went away. So that's a good lesson. The env command will just go ahead and do stuff, whereas the remove command will prompt ahead of time. So that's okay. That's fine. Conda environments are, I shouldn't sweat any bullets because I just deleted it, right? I can very easily create it again. That's the whole point. So if the environment is in a custom location, then again I have to use the prefix option. So I can do conda env remove -- prefix, and then I would do env for the folder name. I'm not going to delete that one, so I have at least one left to play with, but it's the same thing. So when you're activating or removing, you either use name or prefix depending on whether or not it's installed in your home direct, in the default location, or it's in a custom location. Certainly you can use prefix all the time. You would just have to give it the full path. So I can do, prefix home demo 21.conda envs. And if there was something there, I could give that path. So the prefix will work all the time. Name is just a convenience thing, so you don't have to give the full path every time. Okay. Any questions? Otherwise, I think this is probably a good point for a little bit of a break. And then we'll talk a little bit more in depth about packages and channels and all that kind of fun stuff. Any questions? Otherwise, we'll take a 7-minute break and be back at 5 after. Okay. Again, if you haven't been able to get your environment created and you're still behind a little bit, please let us know. We'll do our best to get you caught up. I apologize for the hiccups. Again, this is the first time we've kind of done this, and it's still a beta lesson. So a few rough edges. So I apologize for that. Otherwise, let's take a break. We'll be back at 4:05. Thanks. Okay, let's pick it back up again. Hopefully everybody has refilled their coffee. So we'll talk a little bit about what are Conda packages, and what are channels, and why do I care about channels. So really all a Conda package is a compressed archive file. So if you're familiar with Linux, the term is tarball, but it's a file, or excuse me, it's a file that it's basically an archive of a bunch of other files, right? In the beginning, they used a tar.bz file. More recently, they've kind of created their own format called .conda, but it's, at the end of the day, it's just a archive file. So I can manually unpack a Conda package if I want to. There may be situations where that I need to do that for some nefarious purpose or whatever. But basically, it has whatever the package would contain. So, it would have whatever libraries the thing has, whatever programs, executable programs, the Python module package information, that kind of stuff. It has its own metadata stuff. So that's how it knows what other packages this package depends on, if this package has any conflicts, what version it is, et cetera, et cetera. And then things that are, to be installed essentially. So it has a demo here of a PyTorch, actually, which seems to be the theme of the day, and that's okay. So in this case, if you look in this PyTorch package, so it has a bin folder, and those have programs that PyTorch has when you build it. It has this info folder. That's the Conda metadata. So that's where Conda keeps its information about the package. So it knows what other packages it needs. It knows what the conflicts are, et cetera, et cetera. It has the library folder, the lib folder. So this is the actual, where the actual Python packages is installed, right? So if you're at all familiar with how Python does stuff, there's a Python folder for the version of Python, and there's a site packages folder, and here's where the actual Python package itself. So Anaconda, the company that makes all this stuff, they run a service, anaconda.org. And so that's where people can create what are called channels and upload their packages and make it available for everybody to use, right? So I can search this thing. If I'm looking for PyTorch, I can search that. And it's going to return a bunch of stuff. So the way it organizes things and the way Conda does this is with the concept of channels. So a channel is essentially a collection of packages that somebody has created and made publicly available, right? These channels are hosted on this anaconda.org site. And so, for example, the PyTorch folks, they have their own channel called PyTorch, right? And that's where they put all of their PyTorch packages that they create and maintain. HCC has our own channel. That's where we put a lot of our stuff. So anytime we need to build stuff to install in the cluster, unless there's some sort of license reason or something to prevent it from being public, we put it up on our HCC channel. And then it's available. Does a couple of things. It makes it easy for us to install it because it's public. And then it also makes it available for other folks to use if you so choose. So for example, the recent packages we've uploaded, we just did a build of Julia, Torch Vision, Autodoc GPU, and then some other sort of more support level or library level packages. So you can configure Conda to search some channels all the time, which is what HCC does, or you can actually just specify a specific channel you want to use to install a package. So for the example, let's do a channel called Conda Forge, which I'll talk a bit more about here in a sec. But to do that, I give the -- channel option to the Conda install command. So I'm just going to copy this command so it's easy. So I've got a basic environment that I just went ahead and recreated real quick since I deleted the other one. Again, Conda environments are meant to come and go, sort of. They're, it's not a huge deal if you delete it. You should be able to recreate it. So I'm going to install SciPy 1.6, and I'm going to tell it to pull that package from the Conda Forge channel. Okay, so as you can see, let me find it. Did I say SciPy? Yeah. So actually, I think I did that backwards. Try this again. Is still pulling it from the main channel. Okay, let's try it this way. There might be an issue here because on HCC we actually already configure it to use the Conda Forge channel by default. Let's see here. There we go. Okay, now it's happier. So if you look here, it prefixes the name of the package with the channel that it comes from. So in this case, they're all coming from Conda Forge. There's also a main channel, which is the Anaconda, which is what the Anaconda company, the packages they provide. Let me go ahead and hit yes on this. Let that go. So I can give it, again, it doesn't really matter if I'm doing a named environment that exists in that Conda directory, or if I'm doing a prefix of an environment in a custom location. It's the same thing. It just name versus prefix. So you can actually do multiple channels. So I can pass this option more than once. with different channels. So I can do Conda install SciPy, Conda Forge, and then channel BioConda. The priority decreases left to right. So in this case, the Conda Forge channel will have higher priority than the BioConda channel. So let me just talk about what these two are, so it's not so confusing. So Conda Forge is a community organization. So you'll find their repo on GitHub, and it's a place for people to contribute packages to Conda and make them available. BioConda is the same thing. I've contributed to both those projects in the past. BioConda is focused on bio-related packages. So they don't do anything outside of things that are biologically, bioinformatics, that kind of thing. Conda Forge is more of a general purpose channel. You can pretty much put anything there that's useful. But these are both community efforts, open source community efforts to make more of these packages available for folks. The Anaconda people, the company, they provide a bunch of packages, but not everything, right? They're literally thousands or tens of thousands of packages. And it wouldn't be feasible for one company to provide all of them. So that's where it's really an open source community effort to package things up and make them available with Conda. And there's literally thousands of packages now available for Conda, but not everything, right? So if you really want to get in the weeds in some of this stuff, and contribute a package to either BioConda or Conda Forge, that's kind of a fun thing to do sometimes. You can really help out the community. If you're developing your own package, that's probably more of a relevant use case for folks, because I know not everybody has time to do some of this stuff. But if you're developing your own software, then I would highly recommend that you either create your own channel and make it available that way, or just make it available on BioConda or Conda Forge. And that'll really, really help drive adoption of your software in this day and age. Anybody have any questions about the way channels work? So they're basically just collections of packages that someone has published. So let me cover one more quick thing about the way to specify channels. So this documentation is a bit out of date. There's actually a different way now to specify if I want to install a package from a certain channel. So the difference is, when I do it this way, I'm basically telling Conda to prioritize that channel and look for packages there first. So if there are other packages in that channel that are there, but I don't necessarily want to use the versions from that channel, that's hard. I mean, that's not really possible to do with this mechanism, because Conda is going to prioritize that channel for everything. Okay, so that's the way it was at first. The Conda folks recognized that was a weakness, and so they've done an additional way to specify channels. So I can actually do it on a per package basis now. So I can say Conda install Conda Forge, -forge, and then double colon. So that's saying only install the SciPy package from Conda Forge. If I did more packages, then, so NumPy, Matplotlib, that's going to install those packages from whatever, from the default way the channels are configured. So it's not going to prioritize Conda Forge for everything. It's only going to prioritize it for that one package. Okay. So on HCC machines, we actually configure some of these channels for you ahead of time. You can make this persistent, so you don't have to give that option every time. So if I run the command conda config, I'm sorry, it's conda show. No. On info, sorry, senior moment. So if I run the command conda info, then it's going to tell me what channels that are pre pre-configured. So again, you can use that conda config command and you can make those channels permanent, right? So if you know you're always going to be installing packages from Bioconda, you can add that channel to the list that searches all the time, so you don't have to specify that every time. So on HCC machines, we go ahead and do that. So we add our HCC channel, we add the Conda Forge channel, we add the Bioconda channel, and then it has the default channel from Anaconda, which is called main. So if you're looking for stuff on Bioconda, you don't have to give it that argument on HCC because we pre-configure those. If you're working locally on your local laptop or whatever, then you will need to either do the channel option or you'll follow Conda Forge's instruction, or excuse me, Bioconda's instructions or whatever to add these channels permanently so that they're always searched. Okay. Any questions on channels? Go back to the page here. Okay, so there are lots of things available, but not everything. Again, there are literally tens of thousands of packages, so not everything is available with Conda itself. So there's a few things to do in that case. So first of all, by default, when you first install Conda, it's only going to search the default channel, right? So you could add the Conda Forge and Bioconda channels, and you can search those channels as well. If the package isn't there, if it's a Python package, you can still fall back to using pip, so the Python Package Manager. So some packages aren't available via Conda, but they're available via pip. So I can still do that. I just have to make sure that I have pip installed in my environment. Let me double check here. Usually it gets installed along with Python. Yeah, so pip is already installed. So if I want to install a package using pip, I can just do that with pip. So I make sure that it's installed in my environment. I make sure that my environment is active. So I make sure that it's using the pip from my environment. So then I can do pip install. I think the demo is Kaggle or something in the docs. So it's going to run pip. And if you're familiar with pip, this should look familiar to you. It's going to pull stuff and install any dependencies. And now if I run conda list, right? So conda is smart enough to realize that, hey, I've installed some things from pip or from PyPy. Okay, so that's a sort of a last resort option. You don't get a lot of the niceties that you do with using conda when you're doing stuff with PyPy or with pip. Pip only cares about Python packages. So if you're installing a package via pip that needs a non-Python dependency, that's on you, right? Whereas with Conda, if the package is, assuming the package has been built correctly, even though it's Python, if it requires netcdf, right, Conda will pull in netcdf and install it for you and handle that. So the decision tree is basically use Conda whenever possible. If a package is available with Conda, use that because that's going to get you the best case. And then use pip only when necessary. Okay. Any other questions about that, or we'll go ahead and switch over to using Conda environments in Jupyter, which I think is a handy thing lots of folks like to do. Any questions? I got one thumbs up. I'll take it. Okay. So let's go back to here. So we have I'm just going to refer to our documentation page for this because I think it's pretty good. So the scenario is that I've created my custom Conda environment. It has all my stuff, but I want to be able to use that in a Jupyter notebook, right? So this is how that's possible, and it's for Python anyway. It's pretty straightforward. For other languages, it can be a little trickier, but we'll do a Python demo today and show how that works. So let me put that link in the chat. Oops, that's not what I wanted to do. Okay, so there's the documentation page link. So one thing I'm going to do first is I'm going to get logged into Open On Demand. So if you have, if you're not familiar with Open On Demand, this is a graphical interface that HCC provides. So I'm logged into Crane via Open On Demand right now. So if you want to follow along with this, go ahead and do that. If you just go to crane.unl.edu in your browser, there's a click here to go to the Open On Demand page, and the direct URL is just crane-ood.unl.edu, and then you would sign in with your HCC account. So I'm already signed in. Share the link that has each session slides. Okay, yeah, Colin, if someone could get those links for Sean, that'd be great. So I'm already logged in, and again, I'm logged in as the same user I'm using in my terminal. So when you're doing it, obviously you'll be logged in as you both places. So if you're not familiar with Open On Demand, it's a good interface. It lets you do some things that are pretty nice. I have a file browser, so I can see things in my home directory, and I can upload and download data. So here's my folder. I think we talked about Open On Demand in one of the previous sessions, so I'm not going to go over everything. But one of the things it lets you do is run a Jupyter notebook. So if we want to use our Conda environment in our Jupyter notebook, basically all we have to do is we have to install. So we activate our environment, and we have to install the IPy package. And so that package provides the bridge between Python and the Conda environment and Jupyter. So I've actually already gone ahead and done that, just because I wasn't quite sure how long it would take. But so in my machine learning environment, I did Conda install IPy. So it will install that. And then at this point, I have to run a little command to set up the kernel. Okay. And you can actually do it for R as well. So those are the two ones we have on our documentation. There's what are called kernels. In other words, there is support for Jupyter from many different languages. So it's possible to do it with more than just Python and R, but we just have those two as our example here. So I am going to run the command to do that. So it's python-m and then IPy. So I'm installing the IPython kernel in a specific location for this environment. So I'm going to give this a custom name. Okay. Oops, nope, that should be display name. Sorry. Should be this special environment variable, which is going to be set to the name of the Conda environment. So you can more or less just copy and paste this. If you want to give it a friendlier name, you can change this display name string. So that's up to you. Okay, so it did some stuff. It installed that what's called a kernel spec in a special folder, and Jupyter knows to look in that folder. So let's go back to the Open On Demand session. So here's my Jupyter notebook. Again, I think we talked about Jupyter in an earlier session, but there's some options here for memory. Give it 2 gig, number of cores, running time. If you want to do batch partition or the GPU partition, so you can actually run GPU enabled Jupyter notebooks if you want, if you're doing machine learning things. Oops. So let's go ahead and launch this. depending on how long you're on, how busy the cluster is, and which particular part of the cluster you're running on, this may take longer or shorter to start. For small things, it shouldn't take that long. So yeah, so it's already started. So I can just do connect to Jupyter. And now if we've lived a clean life, if I click new over here, let's see here, is it there? No, of course not. Let's see here. Am I signed in as the right user is the first question. Bear with me just a second here. Okay. Let me try one more thing here. So if you're following along and you got it to work, okay, looks like he's getting an error. Module name IPy Yeah, did you run the IPy kernel install? Conda install IPy kernel? If one of the helper folks could maybe message him directly. See if it's gonna play nicer than this other account here. Oh, okay, I think that's the issue. Okay. All right, bear with me 1 second. Okay, let's try that again. So we'll stop our notebook here. Good. Oops. About 20. Well, where did that go? So we have to close your whole browser. Possibly, yes. I was desperately trying to avoid having to do that. Let me see if I can. A different example here. Yeah, I'm double checking. Login as a sec. I'm playing with 2 user accounts here, so it's possible I got stuff conflated. If you did get it to work, go ahead and put your, hit the green arrow check mark thingy. If you're still having problems, put up the red one. Let's see. Okay, well, I don't want to belabor this. I think we probably have a typo in the thing somewhere. So I apologize for that, but let me do it this way. So here's all the environments that we have pre-canned. So, we have things like Julia, Keras, MATLAB has a kernel even, Octave, of course, Python, R, SAS. Then we have some specific things like TensorFlow. But again, if you need a custom one, then you can create that custom environment and make it available in Jupyter.